You're standing somewhere you've never been. The ground beneath your feet is wrong. Too soft, too hard, the wrong color, the wrong temperature. You have 5 seconds. 1 breath in, 1 breath out. Enough time to register that you are somewhere profoundly far from home. Then you move to the next one. There are 293 moons in our solar system. Some orbit gas giants the size of 1,000 Earths. Some are smaller than a city. Some are volcanic. Some are frozen. Some are covered in methane lakes. Some are slowly being torn apart. 5 seconds each. That's all. You'd think 5 seconds isn't enough time to understand a place. You'd be right. But it's more than enough time for the place to understand you. What would 5 seconds on every moon actually be like? Some would feel almost familiar. Most would not. A few would do something stranger than kill you. Let's start close. Earth's moon seems like the obvious warm-up. It orbits roughly 384,000 kilometers away, about 1 million times the length of a football field, close enough that humans have already stood on it. Gravity there is 1/6 of Earth's. In 5 seconds, you'd barely complete a single slow step, your boot pressing into fine gray dust that behaves less like soil and more like powdered glass. That dust is the thing nobody warns you about. Lunar regolith has never been weathered by wind or water, so every particle is chemically reactive and razor-edged. In 5 seconds, it coats your suit. Over time, it would shred it from the outside in. Mars's tiny moons. Phobos and Deimos are even stranger. Deimos is so small and its gravity so weak that a brisk jog could achieve orbital velocity. You wouldn't fall off so much as drift away into space while your legs were still moving. The sky above these moons is completely black, even with the sun up. No atmosphere means no scattering of light. Shadows have edges sharp enough to cut. 5 seconds, there would feel like standing inside a photograph. But these are the easy ones. The moment you leave the inner solar system, moons stop playing nice. Now, let's talk about the most geologically active body in the entire solar system. Io is Jupiter's innermost large moon, and it looks, from space, like someone spilled a geology experiment. Yellow, orange, white, soft-looking. Pastel almost. Don't be fooled. Those colors are sulfur. Io has over 400 active volcanoes, more than any other body ever measured, because Jupiter's immense gravity squeezes and flexes the moon constantly, generating enough internal heat to keep the interior molten. Surface temperatures near volcanic vents exceed 1,600 degrees Celsius, hot enough to melt iron. Away from vents, the surface drops to minus 130 degrees. Your 5 seconds would land you somewhere between those two extremes, and you would not know which until you arrived. Jupiter's radiation belts make the calculation moot anyway. 5 seconds of unprotected exposure on Io's surface delivers a radiation dose large enough to be lethal. The environment would kill you without raising its voice. Not through explosion or impact, but through invisible particle bombardment, while you were still looking around and thinking the colors were interesting. The solar system has a habit of making beautiful things lethal. Beneath the ice, something unexpected is happening. Europa, Jupiter's 4th largest moon, looks serene from orbit, a pale, cracked sphere, its surface laced with reddish-brown lines like a hard-boiled egg someone dropped. Those lines are the key. Beneath a shell of water ice, estimated to be between 10 and 30 kilometers thick, lies a saltwater ocean that may hold twice the volume of every ocean on Earth combined. Europa's ocean has likely been liquid for billions of years, kept warm by the same tidal flexing that makes Io volcanic. Enceladus, orbiting Saturn, goes even further. It actively vents water vapor and organic compounds from its south pole in geysers that reach hundreds of kilometers into space. Scientists consider these two moons the most plausible candidates for extraterrestrial life in the solar system, not Mars. These. In 5 seconds, on Europa, standing on a flat expanse of fractured ice at minus 160 degrees, faint reddish lines running in every direction. You'd be standing on top of an ocean that may not be empty. That ocean has been there for billions of years. Your 5 seconds barely registered. What if the moon had an atmosphere? Would that help? On Titan, Saturn's largest moon, the surface pressure is 1.5 times Earth's. You wouldn't need a pressure suit. Your body could handle the weight of the air. The air itself would kill you, being nitrogen and methane with no oxygen, but the pressure is fine. Titan has lakes, rivers, and seasonal rainfall. The liquid is methane and ethane rather than water, pooling in pale orange lakes visible from orbit. The sky is a thick amber haze that filters out most of the sun, leaving the surface in a permanent muted twilight. Gravity is 1/7 of Earth's, and the thick atmosphere is dense enough that a human with simple wings could achieve powered flight by flapping. Titan is the only moon in the solar system with a stable liquid surface and a thick atmosphere. In nearly every structural way, except temperature and chemistry, it resembles Earth more than Mars does. Surface temperature, minus 179 degrees. The atmosphere is entirely the wrong molecules. Earth-like in shape, nothing like Earth in practice. This is where 5 seconds stops being a thought experiment and starts being a physics problem. Triton, Neptune's largest moon, holds a surface temperature of minus 235 degrees Celsius, one of the coldest measured surfaces in the solar system. Cold enough that nitrogen freezes solid on the ground. It also orbits Neptune backwards, moving opposite to Neptune's rotation, which means tidal forces are gradually decelerating it. In several 100 million years, Triton will cross the Roche limit and be torn apart by Neptune's gravity, its remains forming a ring system. Some small moons of Jupiter already exist inside this boundary and are actively being dismantled in slow motion. They look like unremarkable dark rocks. There is no visible drama. The destruction is geological, patient, indifferent. Miranda, orbiting Uranus, has a cliff face estimated at 20 kilometers tall. A fall from the top, in Miranda's low gravity, would take roughly 12 minutes to reach the bottom. Some moons won't exist long enough for humans to visit them. Your 5 seconds might outlast the moon itself, on a long enough timeline. Here's the part nobody mentions when they count the moons. 293 confirmed moons is an extraordinary number until you look at what most of them actually are. The majority are small, dark, irregular rocks, captured objects that drifted too close to a gas giant and never left. Not spherical, not geologically active, no atmosphere, no liquid, no distinguishing features. A featureless dark surface, no visible horizon curve, the parent planet not even visible from the most distant ones. Complete sensory silence in every direction. The tour would mostly be like this. Anonymous. The solar system's moon collection is overwhelmingly mundane, which is exactly what makes Europa strange, makes Titan strange, makes Io's colors strange. Without the boring ones, the extraordinary ones wouldn't feel like anything. You need 288 unremarkable rocks to understand why the last 5 matter. You started with 5 seconds. 1 breath in, 1 breath out. Across 293 moons, that's 24 minutes of total time, standing on worlds most humans will never see. Most of those minutes would feel like nothing. Cold, dark, silent, empty. A few of them would be the most extraordinary thing any human being has ever stood on. You wouldn't know which was which until you were already there. Which is the thing about the solar system that keeps being true, no matter how much data we collect. It is vastly, mostly empty, and then suddenly, without warning, it isn't. 5 seconds is both too short to understand any of these places, and in several cases, exactly as long as they'd give you anyway. If you want to see more, click the video on screen now.